A very good afternoon, all the attendees and panelists. The biggest challenge every food processing industry faces today is the lack of advancement and innovation in its manufacturing practices. To bridge this upgradation gap, we at Neologic decided to present an emerging food tech webinar series where we will talk about cost-effective food processing automation, applications of top-notch machineries and technologies, current trends and future directions in food processing sector, and much more. In the 10th webinar of this series, today we will be talking about emerging food freezing and ice cream hardening solutions by Neologic engineers. Few words about today's speaker, Mr. Sri Krishna Ozarkar. Born in middle-class family in Nashik, he completed his entire education in Pune by completing mechanical engineering from Pune University in 1987. After spending a few years in SKF, he joined Alfa Laval and worked in project planning and execution in dairy and beverage sector of the manufacturing department. He started his entrepreneurial journey by starting his own firm in 1996 and eventually merged his business areas with Neologic engineers. Professionally a hardcore technocrat, chartered engineer and valuer, his interests are reading books and Indian classical music. Let me also introduce Mr. Shrish Kashyap, our second speaker today, a mechanical engineer from College of Engineering, Pune, over 39 years of experience in dairy. He joined Alfa Laval in India, in 1981 as a graduate engineer trainee. His professional work includes long stints in Alfa Laval, L&T, and Tetra Pak, covering functions right from project engineering, project management till commissioning and product trials. His expertise are complete plant solutions for dairy, ice cream, cheese, dairy byproducts, and beverage, and including utilities as well. Development of integrated aseptic line solutions for processing to packaging. His interests are like he's a keen follower of current affairs, traveling, and music. So, ladies and gentlemen, let me present our first speaker today, Mr. Sri Krishna Ozarkar. Over to you, sir.
Okay, thank you, Nikhil. So, as Nikhil mentioned, we are going into this 10th webinar now on emerging food freezing and ice cream hardening solutions. And this is based on our earlier tremendous response to various webinars Neologic has conducted in terms of various aspects of food processing. So let me explain you what are we going to cover all today. So let's understand the objectives and the discussion points which we are going to cover in this particular webinar. First, let's try to understand why frozen food. Second, we will also be covering what is freezing and hardening. So when we say ice cream hardening, what is ice cream hardening? Third, effective freezing by IQF. So we have different ways of freezing. So we'll also try to understand what is IQF way of freezing. Fourth, ice cream hardening solutions by Neologic. This topic will be covered by my colleague Shrish. And we are also going to cover all the aspects of whether it is freezing, IQF, ice cream hardening, how this the complete technology, global technology is being manufactured in India and serviced in India under Make in India initiative. So first, let's try to understand why frozen food. So in frozen food, let's understand market scenario as well. The frozen food market is one of the largest and most dynamic sectors in the food industry. In spite of considerable competition between the frozen food industry and other sectors, extensive quantities of frozen food are now being consumed all over the world. Let's also understand freezing and preservation by freezing. So preservation, freezing being one of the best techniques of food preservation, is widely used for retaining taste, texture, and nutritional value in agricultural products or long storage periods since long time now. So what is freezing and hardening? Let's see what is freezing and hardening. So freezing process. The freezing process is combination of beneficial effects of low temperature at which microorganisms cannot grow, chemical reactions are reduced, and cellular metabolic reactions are delayed. Let's also understand freezing for preservation. So freezing for preservation, when we say the freezing delays the spoilage and keeps the food safe by preventing microorganisms from growing and by slowing down the enzyme activity that causes the food to spoil. As the water in the food freezes into ice crystals, it becomes unavailable to these microorganisms for its growth. So ways of freezing. So here we are going to understand spiral freezer. The picture you see particularly in the slide right now is a spiral freezer, and spiral freezer can be used for various applications. It can be for ready to eat items, it can be for fruits, it can be for vegetables, or it can be for many other more items, including your paneer, including your the cheese or meat or chicken and other items. The freezing process in spiral freezers is accomplished with spiral freezers is very popular these times, and that is mainly due to the space saving and energy saving features in the spiral freezers over the conventional freezers. Spiral freezers can be used for a variety of applications, as I mentioned earlier, in the food industry. The second aspect of freezing. So before we go to second aspect, let me explain you some other spiral freezer installations in the photo over here. So on the left-hand side, you see a complete cabinet for the spiral freezer. On the right-hand side, the spiral freezer under construction. Here are a few more photos with the evaporator coils and fans, which are under installation. You can see at the bottom. The second method of freezing is what we are going to talk about is individual quick freezing, what we call as IQF. Now, IQF is one of the best ways for many food items, and it has gained a substantial market in last one and a half decades now. So let's understand effective ways of freezing by IQF. So what is IQF? In food industry, IQF stands for individual quick freezing, indicating that each piece of the food is frozen separately from other. It is not a block, it is not a lump, but it is completely individual piece that is being frozen. That is why it is called as individual quick freezing. Originally, this was developed as a specific solution to block or cluster freezing small size products, preserve quality, and give unparalleled convenience to the end users. This method of freezing has unique ability as it freezes all its products components individually by keeping them separate from each other, which is very important. This makes this very easy for individually freezing and store the product like peaches, berries, grapes, corn, peas, fish, shrimp, cheese, paneer, and other poultry items without getting stick to each other. This technology of freezing freezes each piece individually by using fluidization technique, that is, product is suspended on high velocity air, which leads to the freezing of flood of food products in 10 to 12 minutes, whereas the conventional method can take almost 3 to 4 hours. Thus, most of the properties of the parent food is preserved as a formation of big crystals does not take place, which damages the tissues of food material. Moreover, it also presents the advantage of saving energy, time, as one does not have to thaw or defrost the whole packet to take out only a portion, and the rest shall remain frozen until further requirement. So if I have a block, I don't have to use the entire block. So here, because the products are individually frozen, I can take the quantity which I want and the remaining portion still remains frozen. Another advantage of IQF is ability to separate the units of products during freezing, which produces higher quality products compared to the block freezing. This is also important for food sustainability, as the consumer can defrost the exact quantity as needed, which I explained earlier. So what is the difference between frozen and IQF? So there will be a lot of products which will be appearing in the market. But what is the difference between the frozen product and IQF product? So the main difference is the size and quantity of the frozen product. Cold storage freezing is used for large volumes or bigger size products, such as the whole chicken, packet meat, or the bigger products. IQF, on the other hand, is ideal for freezing smaller products such as small fruits, vegetables, fruit cubes, cheese, pasta, paneer, etc. Mechanical IQF freezers work on the principle of cold air circulation, which flows from underneath the bed plate on transport bed with the help of fans. This cold airflow passes through the pieces of individual product in a circular motion while the product is also advancing through the freezer towards the exit. Here, the temperature of the air is approximately between -18 to -34 degrees, and the velocity of the air is kept very high, ranging between 2 to 5 meters per second. This process is economical for producing many IQF products, as a variety of sizes and shapes can be accommodated in this process. So some of the examples of installation of this particular IQF. On the right hand side, you see the entire cabinet. On the left, on the right hand side of the cabinet, you see the shaker, which is coming out from the product from the inside, control panel, and some photographs of the product inside. So let's understand some of the insights of the IQF, that is individual quick freezing. Commercially, rapid freezing rates are achieved by introducing food products in an insulated tunnel having vigorous circulation of cold air, which I explained earlier. Food commodities are passed through this chilled tunnel on trays and beds. Food is fluidized to form a bed of particles, which is then frozen by forcing, forcing cold air upward through the particles. The upward motion of the air through the bed partially lifts the or suspends the particle, which are then leading to the speedy drying of the particles. One of the advantages of this IQF method by preparing frozen food is that freezing process takes only few minutes, and the exact time depends on the type of the IQF freezer as well as the product. The short freezing prevents the formation of large ice crystals in the product cells, which destroys the membrane structure at the molecular level. This makes product keep its shape, color, smell, taste, and after defrost to a far greater extent. Another advantage of IQF technology is its ability to separate units of the products during freezing, which produces higher quality product in comparison with the block freezing. This is important for food sustainability, as consumer can defrost the exact quantity needed. Rapid freezing also prevents undesirable large ice crystals forming throughout the product because molecules don't have time to form into characteristic six-sided snowflakes. Slow freezing also creates large destructive ice crystals. During thawing, they damage the cells and dissolve emulsions. This is a direct method of freezing. The cold air comes into direct contact with the product, and here the temperature, as I mentioned earlier, is between -18 to -34, and the velocity is between 2 to 5 meters per second. So some of the latest trends in IQF and the features of IQF we'll try to cover. So double blade system, as you can see in the picture, we have two beds, one on the far end and one on the bottom side. So the first one is going to freeze your crust freezing, and the second one is going to be used for core freezing. Then we have a possibility of adjusting the airflow, bed speed, as well as vibration. This variation we can use for different products in a different way. Designed for longer running hours without defrosting. So this can go on for a number of days based on the product and the moisture content, of course. Hygienic design. This is what you can say a hallmark of neologic design, and easy access in 100% made in stainless steel. Insulated floor, insulated cabinet walls. These are going to maintain the desired temperature to what we want. And the evaporator coils suitable for hot gas defrosting as well as water defrosting. Advantages of our IQF design, we will try to cover this. So first is customization. So as such, we do not have any fixed model. We actually prepare every machine based on the customer requirement and to suit his conditions. So based on his product, based on his capacity, based on his requirements, we are actually going to design each and every individual machine. So every individual machine is going to be specifically made for you. So we're not going to sell something which is ready-made or which is going to be made for somewhere else. So it is going to be particularly made for you. Next is Easy Clean. Our Easy Clean design is going to make all points inside easily accessible, as well as they are going to have ease of washing as well as sanitizing. Adaptability, as I mentioned, I can change the flow, airflow, I can change the bed speed, I can change the flow direction. Based on that, I can actually adapt this design for various particular products. And this actually can change the efficiency of fluidization and subsequently crusting and final freezing. ASR system. This is one of our, again, USPs, what you can say. This design completely uses ASR, what we call as an automatic system for removing the frost from the evaporator during the tunnel work. Thanks to our jet of dry, high pressure air, the aim is to maintain constant ventilation conditions, temperature heat exchange as much as possible, reducing the defrosting stops, even running for the several days. This is a typical layout of IQF. Of course, as I mentioned earlier, each and every layout will be made customized to your requirement. So the layout will differ or layout will change according to your site conditions. Some of the installations. So you can see IQF, the shaker on the top, the infeed will be coming over here. It will be going inside the two belts, the evaporator coils and everything is inside, and everything can be monitored from the monitor outside. And on the right hand side, you see some of the photographs of the product inside under freezing.
Yeah, welcome to all the participants for the second session of this webinar. And in this second session, I, Srish Kashyap, will take you through some aspects of the ice cream hardening. Now, ice cream, we have kept it especially as a focus subject because ice cream by itself is a very, very large industry and it is growing at a very large pace. And the size of the plants also is growing up, which by the bigger the plants, the need of the better effective hardening in the entire for the ice cream plant. Now, as far as the ice cream is concerned, once the ice cream is made, you have made a very good product. But unless you harden it, you will not be able to keep it for long. I mean, you will undo everything that has been a good job that has been done in the entire plant. So essentially, ice cream has to be hardened up to a core temperature of -20 degrees for its storage for a long period of time, which is needed very much, until the time it is distributed. And in fact, even at the retail end also, it has to be stored at -20 degrees till it is actually bought by the consumer for actual consumption. Now, as far as the ice cream products are concerned, excepting for a candy product or a stick product that which is made, which is actually essentially in a stick machine, it comes out fairly hardened. But rest of all the products, that is cups, cones, tubs, and the bulbs, has to be hardened. Now, hardening can be done in a hardening room as well. But essentially now we'll just in the next 2 points we'll go into where is the speed of the hardening that plays an important part. Now, in a hardening room, basically the hardening happens in a very, very slow time. It happens over a period of many, many hours. And of course, the room is also occupied in the process of hardening. The cold room is occupied. Whereas in a hardening tunnel, it is hardened over a period of say 30 minutes. So 1 hour or 2 hours, depending on the size of the product. Now, when you harden the ice cream, essentially what happens? The water molecules in the ice cream is actually frozen. And when you're doing slow freezing of the water molecules, the size of the ice crystals are much bigger. Whereas when you do it much faster in a hardening tunnel, the size of the ice crystals are very small. And that smaller ice crystals is what adds to the texture and the mouthfeel of the ice cream. which is a very, very important attribute for the end consumer. So essentially now what we say is larger the size of the plants, hardening tunnel becomes essential, not only for two reasons. One is, of course, you will be not occupying your cold rooms for just for hardening purposes. And also you will be able to get a much better product in terms of the ice cream texture inside. You will be able to retain the design of the ice cream, especially when you are having multi-product and especially when you have ripples in the ice cream. Those designs will be retained when you are hardening the ice cream immediately after it is coming out of the freezer and after its packing. And of course, after the hardening is done, then you can shift it to the cold store where it is kept at again at a minus temperature, minus 25 degrees, till it is distributed, goes to the retail end, and it is until the consumption point. Now, I'll just take you to a few things about the basics of hardening vis-a-vis the temperature. As you see here, you see a curve of temperature versus the ice crystals, percentage of ice crystals frozen. Now, typically for ice cream mix, since it has got milk solids as well as water content, the freezing point of the mix recipe typically say 38% TS is around minus 2.5 degrees. Now, in a continuous freezer, when you are actually producing ice cream, the conventional outlet temperature desired for the ice cream is minus 5 degrees. And at minus 5 degrees, 48% of the water in the ice cream is already frozen. Now, with 48% of the water frozen, ice cream is not yet hard. It is still pliable. It is very soft, and it will not retain the shape. It is not good enough for packing and transportation or keeping it for long storage. So what it needs is hardening. And as I said, in a hardening, what you're looking at is up to a core temperature of the product at minus 20 degrees. And at this core temperature of minus 20 degrees, 87% of the water is frozen into ice crystals. Now, at this particular temperature, it is sufficiently hard enough to be able to retain its shape and as well as other properties, and of course get the ice crystal texture as well, and then it can be stored for a long period of time. There's no need of going lower than this because it doesn't add value in terms of better product retainability. Now, in terms of hardening the tunnel per se, when actually you want to decide what the design of the hardening tunnel and what kind of hardening is required, there are different aspects that really govern the design. So I'll take you through some of the main aspects of it. One of the things that decide on the speed of the hardening and the amount of hardening required is the mix, the recipe of the ice cream mix, the TS of the ice cream, and of course other ingredients that are there in that in terms of stabilizers and what kind of viscosity vis-a-vis temperature that comes out after the freezer. Second part is the percentage water that is already frozen before the hardening tunnel. Now, this is the, we can say, as I said, once it comes out of the freezer at minus 5 degrees, 48% of the water is frozen. But by the time it is packed and it is going into the tunnel, you may lose 1 or 2 degrees. It may enter the tunnel at minus 4 or minus 3 degrees. Now, this is an important part for us to get from you as a manufacturer, these exact temperatures and the conditions for us to design the tunnel properly for you. Now, another very important part is the freezing air temperature. And of course, the lower the temperature, lower the air temperature, it is better that, in terms of a speedier hardening that can be possible. And of course, here we have different refrigeration temperatures that are possible. There are, in fact, in terms of refrigeration, you have freon as well as ammonia. Of course, we will not get into the where freon and ammonia will be required. That's a separate topic altogether. But I would say a temperature of minus 40 degrees should be good enough for a good design of a hardening tunnel. The wind velocity in the tunnel, and these are, of course, now we are getting into the design aspects of the tunnel. The number of fans, the size of the fans, the way the air is circulated inside the tunnel, with the number of baffles that are placed inside. And this becomes a very, very important part in terms of taking out the heat and freezing the ice cream. And of course, the way the products are loaded onto the tunnel, or onto the belt of the tunnel is also very important. This is where again we will be able to get from you, guide you as to how the loading pattern can be, so as to get a better flowability of wind or the air, cold air over the product. Another important part is the air turbulence between the products. This is where I would say, again, the design of the belt, the way the products are loaded, and the way the secondary packaging is done also plays a very important part, where we will be able to understand what your need is, and then we can be able to guide you better into how the products can be loaded. Here also very important part is when you're looking at, say, cones. Cones ideally should be actually hardened when it is put in upright condition, so that from the time it enters the hardening tunnel at -5 degrees till it comes out, the shape of the ice cream in the cone remains as it is. But in sometimes it is not possible, because if the cones are kept sleeping down, the ice cream tends to flow in the beginning, and that it will the shape will be destroyed. So of course, the temperature of the cone as it comes out of the freezer plays an important part over there. And of course, a very important part, and finally, is the packaging material. The primary and the secondary packaging material. If the cones in the cups are kept in a boxes, what is the size of the box? What is the material thickness and the material type, and the amount of air it leaves into the ice cream, into the product, that makes a very important part. And this is something that we look at it together when we are deciding the tunnel for you. Now, friends, we will look at some of the hardening solutions from neologic engineers. Now, neologic engineers, we are actually manufacturing hardening tunnels in India. And these are, of course, both spiral as well as straight line tunnels. And I will take you through some of the salient features of our tunnels. I would touch upon more on the spiral tunnels because these are ones that are more complex, and more and so the tunnels are required for high capacity plant, where invariably a spiral tunnel is needed. Now, in case of the neologic tunnels, we have some of the features that are which add to your reliability. We use a direct drive belt, and the drive is placed outside the cabinet, including the gearbox, and that makes it accessibility as well as maintainability much faster. And of course, the direct drive is much more efficient in terms of not only the power consumption part of it, but it's also very we can say efficient to ensure that the belt breakability is reduced to minimize, I would say, to a large extent. Also, very important part is the airflow. As I told you, we use a tangential airflow and tangential horizontal airflow. You can see in some of the small diagrams that we've shown, one of the spiral tunnels need as many as four fans for efficient airflow inside the tunnel. And this design of ours is what makes essentially means that we had to have more fans inside the tunnel, and of course more fans means it adds to the cost of the tunnel, but of course it adds to the performance and the reliability of the equipment. Our tunnels, some of the other good features is the long working cycle, and the one very important part which aids to the long working cycle is the fin spacing of the fins in the evaporator unit inside. And we have a larger fin spacing, and of course the evaporator is also oversized because it has to take care of a lot of other conditions which are not possibly expected. It could be large amount of humidity in the ambient air. It could be the large humidity because of during rainy season it comes in, and of course the conditions in the production hall itself. It varies a lot, so we need to size the evaporators for the worst condition. And of course, to that extent, our evaporators are larger in size, and of course, it adds to our cost of the equipment to that extent. And one more important part is that our insulated cabinets have higher thickness. We are saying this because Of course, while we are choosing the thickness as per requirement of the Indian tropical conditions, we have also seen that some of our competition which are coming from say Oriental countries, say China, they are designed to very minimalistic, and they have a much lower insulation cabinet thickness, as we have seen it in practice ourselves. These are also a very important part, the cleanability of the tunnel, because the hygiene conditions and the sanitary conditions inside the tunnel had to be maintained. And as we see that during the process of hardening, some of the smaller products tend to fall off the belt. So over a period of time, the products had to be cleaned out, and ice cream, particularly matter if it is fallen down, has to be cleaned out, so as to maintain the sanitary hygiene conditions inside. In our case, we had to look at, there are two separate parts. One is the belt cleaning and the other is the drum and the inside portion cleaning. So for the belt cleaning, we have a belt washer at the beginning itself. And of course, for the inside cleaning, we use a high pressure jet pumps, and then along with the nozzles strategically placed inside. We use adequate number of nozzles at all the places where it is on the belt and on the floor as well. And make sure that the system operates in an automated manner, in a sequentially, so that all parts of the hardening tunnel are cleaned efficiently. Another part of the tunnel is the safety aspect. This is just one part I just want to touch upon. There could be others as well. This is about the safety system for the overhead products, because if accidentally the operator places a product over product or bigger size products, it will ultimately result in a lot of jamming of the products inside, and we have to, and then it will be resulting in a stoppage of the tunnel. And so this is a safety feature for that. And of course, we use hot gas defrosting as a standard, because that is much faster, and it saves much faster, and then it saves a lot of production time that is not available during the period of defrosting. Of course, there's optional hot water defrosting also available, and this based on your requirements, we can suggest, and you could decide which one you want to go in for. To continue further, I would like to touch upon some aspects where we have an edge over other makes, and this is basically the high efficiency of a system. More in terms of the availability, it's our hours availability for production. And this comes because of two things. We have a air filtering system, which is a uniquely designed by us, which catches the moisture before it goes onto the evaporator. And also we have a system further on, as my colleague explained earlier. We have a system by which we are able to take out the frost on a periodic manner, and during that happens during the production cycle itself, so as to extend that, to minimize the ice buildup on the evaporator and to extend the defrost time interval that is required for the hardening tunnel. So this essentially means more production time available, and of course lowering the overall cost of your operations. One very important part, I would say this is actual data that we have captured. I would say not from a difference from the, say, European makes of tunnels that are available to you, but those are being imported. I'm comparing with that of some of the Chinese makes. This is the actual comparison of our design versus theirs. Our thermal load requirement was 27% lesser, and because of our efficient direct drive system, and also the selection of fans and the specification of the fans, we have a 40% lower electrical load. And these two things, of course, result in a much lesser operating cost for you. And we'll have some actual comparison and figures I'll show to you as we go further into this presentation. Some other aspects apart from this, where we make sure that the design is more optimum, is on the belt width and of course the drum diameter. As you said that we design the tunnel for each application separately. We customize it for a very optimum operation and reliability. The belt width need not, we don't go with the standard belt width based on what we have as a standard, but since we source a belt from reputed belt manufacturers globally, get the belt of the right width and the right material as well for your product, and accordingly we'll also select the right diameter of the drum, because that makes a very important consideration from a torque point of view, and ultimately the continuous operation and reducing the belt breakage. That aspect is much more handled properly out here. A lesser belt width or a lesser diameter means also means more number of tires, but at the end the extra tires will add in two things. Of course, it helps in a better load distribution, a better cooling distribution, but it also helps in a lower footprint in occupying the floor space in a production hall. As I said, because of these things, our tunnels, we have seen that our floor space occupied is almost 15% lower than some of the very standard Chinese makes available. Now, this is a chart in front of you, a table where we have compared our data of a 2.5 tons per hour or 2,500 kgs per hour of capacity hardening tunnel, approximately 4,000 liters per hour. And then, of course, the data from the other Chinese make is there. There are a number of other data points, but I would like to just focus on two things. The thermal consumption in our case was 221 kilowatts. This is a thermal load. And in case of theirs, it was around 300 kilowatts. And the electrical load, we in our design, it was 35 kW, and in their case, it was 58 kW. There are other, of course, there are other positive points in our case, but just looking at these two, this for a plant that is running continuously for around 18 to 20 hours per day and around 250 hours per year, this reflects into almost a 1.2 crores operating cost saving for you. And I would say in a normal, standard way that the extra cost that possibly you would pay for our tunnel vis-a-vis a Chinese tunnel, it can pay you off in just around say 2 years, and thereafter it is a net saving for you year on year. So this is where I would say a neologic equipment makes sense in the overall scheme of things. Further on, I'll just like to show you a typical layout of a double drum spiral tunnel. As you see out here, this is the same capacity I talked about, 4,000 liters per hour, and it has got a floor space around 13 meters length and 6.5 width. And this is a typical layout, but of course, this is as it was required for a particular plant, and we can customize it to the inlet from whichever side you want and the orientation you want, and the outlet can be of a different orientation as well. But having talked about the double drum, I would also like to add that we can also make a single drum tunnel for you based on your plant layout. If your storage is on the first floor, it makes sense that you have the products taken up, hardened there, and then it goes after hardening directly into the cold rooms on the first floor. And it can be the vice versa as well. So spiral tunnels can also be manufactured and fully customized as per your requirement. Now, talking about solutions from Neologic, and I like to once again touch upon our full flexibility in designing it for you, not only in terms of the number of drum requirements, but also in terms of the orientation. Also, what we want take from you is what are you using the the tunnel for? Is it for the bulk products only, or is it for the bulks and the small products also, or it is only for the small products? So accordingly, we will be able to design not only the thermal load, but we will be able to design the belt and the drum diameter for your specific requirement. But if you want to harden both the products together, then of course we can also design the belt with a partition in between, so that you can have a small products at one side, bulks at the other side, so that at the exit end, you are able to take the products to the requisite place in the hardening room. It will be easier for the further distribution and pickup by the operators. Our tunnels are fully, I would say, PLC controlled, and with a color HMI. And for the different products, we can build in different recipes in terms of the time required, in terms of temperature. Yeah, in fact, you can customize it, and you can have a operator control features for fan speed as well. And all these are, and this can be even communicating data with your main SCADA to know, to have a full data about the hardening operations that are happening in your plant. And apart from that, of course, since it is manufactured in India, we have our service team located in India. They're available 24/7 for any video call support, for any we can say logic support that you need. But if you need any person required at your plant, he can be there just in a day's time, and that will ensure your minimum downtime that you'll have. And of course, you can undertake annual maintenance contract also to ensure that your equipment is running continuously without any stoppage. And I like to finally add that we have a wide range of experience. Nologic has been manufacturing a number of spiral tunnels and for different applications, and our teams are fully experienced to design, manufacture, and maintain them for you, and after sales service for you for long years to come. As I said, our tunnels are made in India, fully manufactured and serviced in India. And these are some photographs of the spiral tunnel during process of manufacturing at a shop floor. On the left hand side, on the right hand side is another straight line tunnel being manufactured for ice cream applications. So these are a few photographs to share with you. So this is where it is. I come to the end of my presentation on the ice cream hardening solutions. During this process, we touched upon the basics of the hardening for ice cream, and then of course the typical requirements of hardening tunnels which is required, and of course some of the salient features of Neologic hardening tunnels here. At this stage, I would like to invite you to ask any questions that you have, and we'll be very, very happy to answer that.
Yes, we'll start the question answer session.
Yeah.
The first question is from Mr. Mohammad Hassan. He has asked, can we use IQF to freeze ice cream?
Well, the design of the IQF is different. It is, as we covered earlier, it is for actually designing, hardening very small products. It could be like peas or small pieces of vegetables. Ice cream is a different kind of a product. The requirement of hardening, freezing ice cream is a different thing. And well, in principle, you can use it, but it will not be efficient. I mean, it will not be the right way to do it. But both are the same. Equipment wise, it is the same, but design wise, it will be different.
Next question is again from Mr. Mohammed. Is that IQF working with ammonia, freon, and nitrogen?
Yeah, I mean, as a backup refrigeration system, you can design it with the backup refrigeration system for ammonia also, for freon also. The only difference is that the evaporated design changes when you're using ammonia system or vis-a-vis a freon system. But essentially what you need is a temperature and amount of air. And coming to the nitrogen is a different kind of hardening altogether. I think it's a totally different technology. Hardening, of course, the process is the same, but it's a totally different technology and equipment. I don't think we will cover it at this stage right now. It's basically, we are talking about basically the refrigeration being either freon or ammonia in this case.
Another question is there from Mr. Rahim Ali. He is asking, what do you mean by tangential airflow?
Yeah, basically the air that is coming in from the fans has to first to give it in terms of principle. The coldest air has to come to the product and freeze the product immediately. So as the product comes into the tunnel, it comes at one side and it comes to the outer side where it is a side. And when you are forcing the air tangentially, this air goes and meets that product to immediately freeze the product. So that's where the tangential entry makes a, that's what is needed. And as the drum moves, the air also moves along with that to start freezing the rest of the product on the belt.
Okay. Next question is by Mr. Satish. What is the limitation on product thickness for selecting IQF or spiral freezes? So I believe for IQF, we can go up to even 25, 30 or 40 mm. Beyond that, it becomes a block, and then the efficiency is more into the spiral freezers. So typically IQF are used, like we say, individual quick freezing. So smaller particle size or smaller fruits, vegetables, paneer cubes or cheese cubes and other things. So 25, 30 mm is also possible for IQF. Next question is from Mr. Balaria. Can we use IQF for paneer cubes to freeze? So of course, as I mentioned earlier, paneer freezing is one of the most important and very popular application for IQF, and Neologic has got good experience in that as well. Next question is from Sukanta Chakma. What is difference between IQF and BQF technology, temperature and quality? I believe this will require an elaborate technical discussion. So what we can do, Sukanta, we will write to you separately about this, or we can have a telephone call about this. Mr. Suresh Rathwa is asking which gas is used for hot gas defrosting.
Well, the gas that is used in the refrigeration system, the same gas it comes directly from the receiver as the hot gas. So if you are using a refrigeration freon-based system, it's a freon gas. If it's ammonia-based system, it's ammonia gas that comes in for that defrosting.
Okay. Next question is from Mr. Ravindra Thapre. He is asking, to avoid frosting, are you using dehumidifier?
No, we are not using a dehumidifier at this stage, in this case.
Okay. Question from Mr. Shu Yuan NG. What is the lowest temperature it can meet in order to achieve fastest freezing, not to take product size into consideration? Lowest temperature it can be achieved in the freezers.
Well, actually, when we're talking about the chilling media, that is, of course, the cold air, and the cold air is, in fact, is then the refrigerant system that is designed for, say, minus 40 degrees. Will generate a cold air of around, say, 35 to minus 35 to 40 degrees air. We are looking at a product, certain core temperature at the product, which is minus 20 degrees in case of ice cream. And of course, as you see, as you measure the temperature of the product till the surface, then of course it will be a minus temperature. It could be minus 25, it could be minus 30 degrees. Now, of course, there's a gradient of temperature for the product. I mean, more specifically, if you're talking of say a bulk of an ice cream product. And now achieving a temperature below that will not add any value. It doesn't add any gives an advantage to you in terms of storage of the product or its properties.
Okay. Mr. Nagasiddha Reddy is asking which cooling system is better, air or water?
Well, in case of ice cream, definitely it has to be air, because we are not talking about ice cream hardening. Air is also used for a lot of other products. But yes, now actually we are talking about freezing. We are not talking cooling now. So it is frozen using air as a medium only. Definitely, I mean, what you mentioned as water as a cooling medium is for coolers, and it's for water coolers. And then it doesn't go into the domain of freezers or hardening. It is just coolers using cold water.
Okay. Next question is from Mr. Vinod Reddy. Can we use it for diced avocado? Freezer, so freezer can be used for
Yes.
diced avocado.
Yeah, it can be.
It can be. Mr. Satish is asking, post freezing in IQF, how long the product can sustain its temperature before entering into cold store? I think this will depend on the product configuration more.
Yeah, it all depends on how you're handling the product at the outlet. Once it comes out of the IQF or the freezer, and to how much time it is spending to the ambient conditions before it enters the cold store. What are those ambient conditions? Is the product really exposed to the ambient air directly, or are you actually putting these products in a separate box, and then you're actually ensuring that the ambient conditions don't it doesn't the temperature doesn't come up. So it all depends on how much time it spends outside and how you handle the product outside.
Okay. Again, Ravindra is asking, I think you have already answered this question, whether we should use ammonia or the tunnel.
It's basically up to your plant. I mean, I would like to add here, since you asked the question, and very often than not, for a hardening tunnel, for higher load, there's a dedicated refrigerant system people going for, because it can be controlled to and operated to the requirements of the hardening tunnel itself. But it's also possible that if your plant is a big size plant having a central refrigerant system, having minus temperatures, so you will be requiring, say in that case ammonium at minus temperature of minus 25, minus 30 degrees, minus 35 degrees for your freezers, for your say hardening tunnel for the extrusion line. Also, because if you are having an extrusion line, it has a separate tunnel by itself. So you can have a central refrigerant system, and if it can give minus 40 degrees, generate minus 40 degrees refrigerant for your hardening tunnel, it can be used as well. It all depends on how the design is being. But if you have a smaller plant, if you are the only product in your plant is your hardening tunnel, then you can have a dedicated refrigerant system for that, and it will be efficiently designed for that. And just to add out here, why ammonia or freon? I think though the question is outside the ambit of this discussion, I would say that if your plant is very much in the city, and if your local conditions don't allow you to use ammonia, you have to use freon. And second is, of course, in terms of power consumption, ammonia uses lesser power compared to freon. But ammonia systems are more on the capex, they are costlier than freon. So these are the two things which are pertaining to a refrigerant system. But yes, that's something that you can decide. And as in when, of course, a producer would approach us for a tunnel, and he wants our support on optimized refrigerant system, we can guide them on that as well.
Okay. So Shirish will try to take last 3-4 questions now.
Okay.
2 questions are pertaining to whether we have installation near Patna, and one person is asking whether it is near Singapore. So to answer Patna, we do not have installation for freezer, but we do have installation for a complete dairy unit. So we can take this offline and on the mail. And Singapore, we do not have any installation right now, but we have installations in other European countries, including USA as well. Next question is asked by Mr. Deepak. What are the typical sizes for ice cream hardening tunnel and IQF?
Sizes for the hardening tunnel, as you said, it is totally customized. We don't have standard dimensions, either in terms of the size of the tunnel or size of the drum or size of the belt. It is totally customized to your requirement. Because as you said, all the major components like belt, we source it from manufacturers, and we can get whatever is required. And same with the drive and other critical components of the tunnel. And as far as your requirement is concerned, based on your specific requirement, current as well as future, we will get all the inputs from you, and we'll design the tunnel specially for you. And same, I think, will hold for the IQF as well.
Okay. There is a question from Mr. Rajiv. What is better according to you, linear tunnel or spiral tunnel?
Well, a linear tunnel is more suited for smaller products. It could say for cups or small tubs, or even say linear tunnel is very well used for the extruded products. Now, there are different things. I mean, for this smaller product, sometimes you need a different kind of a belt, or we can say a holding plate, I would say, and which has got certain holes to keep the product in a certain way, maybe in upright condition. And the design of this particular tunnel is for us, is this particular smaller cannot be loaded on these kind of belts, and hence I would say these are more for smaller products. Also, it occupies a longer space in your floor, in your production hall. It is much longer in length, and of course lesser in width. But as I said, we have to look at what your products are, what is the available space in your production hall, what is the height of your floor, I mean, available from your floor to the ceiling. All these factors will decide. And of course, spiral tunnel has got a lot of other advantages in terms of, I mean, we can say loading a lot of other different kind of products, be it bulks, be it small products. You can also increase the capacity of the tunnel. If you increase the refrigeration capacity, and you can upgrade your fans as well later on. So there are a lot of advantages of the spiral tunnel, and of course it costs a little bit more compared to a linear tunnel. But all these things we can look at it individually once you come ahead with your requirements to us.
Okay. So while we go on to the last question, I request all the panelists and Kashyap sir to start your video so that everyone can see you, and the rest of the questions which remain unanswered, we can take it offline or by email. So the last question, yeah, this is from Mr. Shriram. He's asking, we have seen a lot of issues in Chinese tunnel. Your views on the same?
Yeah, you are rightly expressed your observation. There are a lot of issues in the Chinese tunnel. Now, the reason being, of course, the quality of the components. What we use are branded components which are made for that specific requirement. These are globally branded, available products globally. And whereas the ones in the Chinese tunnel are made in China, whose we can say the design quality, manufacturing quality may not be up to that particular standard. The Chinese tunnels are made in huge numbers. They are, we can say mass production of a particular size, of a particular belt size, of a particular drum size. And these are standard sizes. The cost of production, of course, goes down when you are having a mass production. At the end of the day, of course, the raw material costs and other things go a lot into that. But I would say from a design point of view, they are designed very, very minimalistically to keep the cost down to the minimum possible. And it is not the performance or reliability that is the requirement there. It is basically the cost. And secondly, you don't get spares for those tunnels in India. And you'll have to start making your own spares when you require. And third is, of course, the service support. I mean, there could be some local engineers who are not really well trained or well knowledgeable in terms of those equipment. And having engineers trained professionally for your product, and for your design makes a lot of difference when you buy equipment which are made in India, but made with global standards actually.
I believe, Shrish, it is also, when we are talking about Make in India, we should promote Make in India products as well. That is also one of the aspects that people.
Yeah, of course. That is the whole focus of the nation as well now, that we had to be self-sufficient to meet certain contingencies that can occur anytime now, because the global conditions are such that we can't be getting restricted by supplies, restrictions supply chain from outside countries. We had to have our all the requirements met within India, and that's the way to go ahead actually.
Yes. Thank you. So over to you, Nikhil, for the rest of the things.
Yeah. Thank you very much, Ozarkar sir and Kashyap sir, for this insightful session. Moving ahead to all the attendees, these are our few previous webinars. You can check out the recording of these webinars on our official YouTube channel. So can we have the next slide, please? Yeah. So these are upcoming webinars: new age dairy plant automation, hygiene or sanitary manufacturing practices, which is very needed and important for food industry. Current trends in UST milk processing, automation and hygiene go hand in hand. These are few upcoming webinars. So you all will get notifications of these webinars on your email addresses as well as on our social media properties as well. Yeah. So can we have next slide, please? Yeah. Please take a screenshot of this slide. You can get details of our email address, mobile number, and our website as well. After this session, you will be redirected to our YouTube channel. You can see recordings of our previous webinars as well. Thank you very much. Thank you all the panelists. Thank you all the attendees for joining.
Thank you, Nikhil.